this function is given, we have to find the stationary points and point of inflection if there is any. So let's start it. To find stationary points, we know we have to find y prime and equate to 0, because at stationary point the gradient of tangent is 0. So y prime is 3x square minus 12x plus 9 equals to 0. So we can divide both sides by 3. It becomes x square minus 4x plus 3. And then if I do middle term factor, becomes like this. So x minus 3 there and x minus 1 there. So x is 1 or 3. And when x is 1, if I plug in here the value, I will get y. So this is 1 cube minus 6 1 square plus 9 1 plus 1. So that's 1 minus 6 plus 9 plus 1, which is 5. So that's 1, and then so 1 point will be 1 and 5. To find the other point, let's plug in x is equal to 3 in the function y. So that's y. I will write it again, x cube minus 6x square plus 9x plus 1. So 3 cube minus 6 to 3 square plus 9 into 3 plus 1. So this is 27 minus 9 times 6, 54, plus 27 here plus 1 here. So 27 plus 27 is plus 54 minus 54, so that's gone, so it's just 1. So the other point is 3 and 1. So two stationary points, one is 3 1, another one is 1 5. So we know that. Now we have to see whether this point is this one and this one, which one is maxima, which one is minima. So let's do that. Let's find y double prime. So we know y prime is 3x square minus 12x plus 9. Let's rewrite it. Y prime is 3x square minus 12x plus 9 minus 12x plus 9, that is y prime. So y double prime will be 6x minus 12. So that's y double prime. So at x is equal to 1, y double prime is, so what we are trying to do is, one of the stationary point is 1 and 5. So I'm trying to find what is the sign of y double prime, that is the second derivative, at that x. So just plug in the value of x here, 6 into 1 minus 12. This one gives 6 minus 12, which is minus 6, and that's a negative sign, and that means this is less than 0. So this point is, since this is less than 0, this point is a maxima. So that's a maxima. We know 1 and 5 is maxima. Let's just write that maxima here. And the other one, when x is equal to, the other one is x is equal to 3. So plug in here again. Y double prime is 6x minus 12. So 6 into 3 minus 12, which is 18 minus 12. So that's 6, which is greater than 0 or positive. So that's a minima. So this one is a minima. So 3 and 1, this one is minima. So we know both the points. So now we need to find if there is any point of inflection. So that in order to find the point of inflection where the concavity changes, we have to equate y double prime to 0 and see if there is any solution for x. So let's do that. 6x minus 12 is equal to 0. That gives us 6x is equal to 12. So x is equal to 2. So 2x is equal to 2 is the point of inflection. Whether it is a point of inflection or not, we have to actually double check, but we will do that later. Let's see what should be the value of y there. So y will be x cube minus 6x square plus 9x plus 1, so 2 cube minus 6 into 2 square plus 9 into 2 plus 1, which is 8 here, 24 here, plus 18 here, plus 1 here, that gives 3 there. So point of inflection is 3. So we know several things now. We know enough actually to be able to plot the graph. So the maxima is 1 and 5 is maxima, 3 and 1 is minima. Let's double check there. So 1 and 5 is maxima, 3 and 1 is minima, and 2 and 3 is point of inflection. So 2 and 3 is point of inflection where let's just write this one. So 1 and 5 approximately there, that is a maxima. So the curve will be, and 2 and 3 somewhere there is the concavity, where the concavity changes. And also we see that this one, where it is 1 and 5, we know if the second derivative is negative, that's a concave down. We also know that, and if that's a stationary point, that's a maxima, that's fine. But also for any point where the second derivative is negative, it's a concave down. So things are falling in place, it will be like that. And then at 3 and 1, this is 2 and 3, which should be a point of inflection. 3 and 1, maybe somewhere there, is the minima. So like that. And this one at 3 and 1, which is a minima also, but the second derivative is a positive. Since it's a stationary point and the second derivative is positive, so it's a minima. But even if it was not a stationary point, since the second derivative is positive, it means this is concave up here. So this is where the point of inflection, which is 2, 3, and before this one, so to the left of this one, this is concave down, and to the right of this one, this is concave up, and this point is the maxima, which is 1, 5, of course it's maxima, and this one is of course the minima, which is 3 and 1, sorry, just rewrite there quickly, 3 and 1, which is minima of course, and this one, as I said earlier again, but just this is where the concavity changes, and that's the point of inflection. I don't know, it's not an valid abbreviation, I've just written it. So point of inflection where the concavity changes. So yeah, I won't make this video any longer. This is just an example, and yeah, I will try to do more later.